I'm not, I tried to find tasks in the field, I hope I was successful, but I like this Japanese task from 2014. Johnny has 8 photos. He would like to leave one of them to Bella. He asked her some questions to find out which photo she wants. Do you want the photo with each umbrella? Yes. Do you want the photo where I have...
In exam questions that I write difficult conditional statements to try and test exactly this logical thinking. And it's something else that's important when you're writing algorithms.
And also we should age. You should also choose some tasks that they will be interested.
So,
Yes.
No.
so one question, I mean, example of how do students think that they do this sort of? What's going on in your mind? I mean, I would love to see it explicitly, ask them to write a drawing or like a little diagram, right? What is happening? What do you do first? Okay, do you want to follow with each umbrella? Yes, okay. So what is the first thing you do? And then what's the second one? And I think the computational thinking will come when you tell them to write the process of thinking or something about their process. I'm not sure if you're doing it, I'm just curious about it.
So this is, I wanted to just more like in a few years, you can check on webros.org. There's many publications. It's like around 100 already publications from different countries, in different languages, and different magazines or conferences. So you can, now we are trying to overview, and we are starting with several countries.
We are both measuring mathematical education, and we are just researching about the coding education and about coding, so we are now expecting your workshop.
Okay, thank you.
My name is Gerald, and same.
So we,
Hello, everybody.
everybody, they presented themselves, so just you. I asked.
It's not like I did you. Thanks.
And you are interested in what you are interested in? Teaching mathematics or
Coding education.
education, coding.
Coding mixed method.
Methods, it's mixed method, yeah. Okay, thank you. You?
I'm usually we are all Korean.
Oh, Korea, many Koreans. So Korea will join members this year. So that's why there are a lot of Koreans.
Excellent.
Excellent. Very good, very good.
We are interested in.
Sure. I don't know this.
Okay.
We are interested in construction, computational thinking, and related to everything. So we are here.
Thank you. Thank you.
I'm Laura Benson. I'm from UCL Institute of Education and Mathematics, and with part of that is very developing computational thinking in primary school pupils. And I've heard a bit about this from Ivan, so I'm quite interested.
You are in the same group as Ivan.
Yeah.
We are working for this Ivan maybe more than 20 years.
Yeah.
I am José Valente from Brazil, from University of Campinas. I'm involved with local since 1976, when I did my doctorate with Papa. And now we even have this session about reviving programs, because now it seems that we are coming up with this opportunity that programming again, because of this computational thinking idea, is very, so that's why I'm interested.
My name is Elena Prieto. I'm from University of Newcastle in Australia.
maybe in MIT also for some months. Okay, so,
So, you introduced yourself?
yeah, okay. I'm just Valentina Dagiene from Lithuania. I'm working at Vilnius University. And so I established this Bebras contest in 2004. So it's 12 years, almost 12 years ago, and we started with several countries, and now we are growing and growing. So, Gabrielė?
I am Gabrielė, PhD student. My name is Valentina, and I work about 5 years. I'm a little bit past, about 5 years. So, my experience.
So my name is Gerald Futschek from Austria, from Vienna University of Technology, and I'm involved in Bebras since nearly the very beginning, and do also task development with my students, and I'm responsible for the Bebras Austria.
Okay, let's start.
Yeah.
So, I think we give, at the beginning, we give some information about the Bebras contest. Have you been at the lecture this morning? No, I don't think. So, we will show what it is,
Very short, and then we will.
and then we can start with the tasks. So, the goal of the contest is that the students develop computational thinking. So this is why it is called the challenge on informatics and computational thinking. And we call it challenge because it is not testing, or it is not competition. It is more the activities that the students do it is important, that they solve problems. It is a problem solved, the Bebras challenge. And we want to stimulate the interest of the pupils. So we address all pupils at school, not pupils in computer science lectures only, but all pupils at school, from primary school to the until graduation at school. So everybody should participate, girls, boys, classes, everybody. And we want that the pupils thinking about problems. And while solving problems, the pupils learn how to think computationally. They don't need any pre-knowledge. This is an advantage of this Bebras challenge, that we can, everybody can try to solve this task. Maybe they are not successful for some tasks are harder, some tasks are easier, but everybody can try. And it is on problem solving, and this is important in computer science and informatics, that the ability of solving problems. And not to know something about how these different concepts are named, how the parts of the computers are named, and so on. So, which slide?
Yeah,
This one. So, you see this is for all age groups. We didn't start it so far with the first grades because we need some reading ability to understand the tasks. We have tasks that are interactive. They are very attractive, also, especially for the youngest ones, to do something, to play with the computer. And while moving some objects or connecting objects and so on. While they are doing it, they are solving the task. It is on PCs, all tasks on PC, and nearly in all countries it is web-based. So it is on the web, and the advantage of the web, but it is not a must, but it is the fact that it's web-based. Yes, you heard about the countries. We had 36 countries 2015, and in total 1.3 million participants, most of them in France, and also a very lot, a 250,000 in Germany, but also the other countries are very good. And some are just beginnings, they have less participants, and some do it many years, they have more participants. And we are inviting further countries to participate. This is also important that we want that we have more countries. And I said already, this is a contest, a challenge on thinking. And they have to develop solving strategies. If they get a problem, they have a strategy how to go on. And this strategy comes from computer science. These are computer science related tasks, but adequate to the age. But I show many examples afterwards. So it is on problem solving skills and computational thinking. I think you are familiar with computational thinking. Yes, you said it, so I can do it faster. This is now very fashionable, this word. And because we are constructionists here, what we try is that there are constructionist elements in this Weber's concept. For example, if the students have to solve a task, it should be, a good task should have different ways to solve it. Of course, these tasks are small. We have about 15 tasks to solve in 40 minutes. But this is a short time. So we have, in average, per task, 2 to 4 minutes. This is a very short time. So we cannot have, it is different to a project you do in the class. So these are small problems to solve, but still there should be more than one way to solve it, and it should be funny, and it is desirable to have it interactive. But interactive is a lot of effort, and it's not so easy to implement. So now not all countries have only interactive tasks. France, for example, has only interactive tasks. They have a lot of manpower. It is good to have them. And on the other hand, we have teachers and specialists who are developing tasks. For example, my students at university, the students want to become teachers afterwards, so it's a good education to create tasks and good tasks. And Weber's tasks are not so easy to have good Weber's tasks. Have so many. What's the need? So many different
iterations.
Yes, we have many iterations, and they have to fulfill so many criteria. This is so it is not so easy. And these teachers learn. This was topic of our talk this morning. The teachers learn to create tasks on one hand, and on the other hand, they have to analyze these tasks.
And this is a deconstructionist process, to analyze, to decompose the task. What are the thinking abilities needed to solve this task? What are the aspects of computational thinking that is used? What are the concepts, informatics concepts that are involved? So this is an analysis task, and they have to describe why process to creating tasks and to write this. This is informatics, because at the first glance you don't see that the task is from informatics. So yes, we have this interactive, some tasks that are assigned to these different categories of computational thinking. For example, formulating problems in a way that enables us to use a computer and other tools to help solve them. Okay, this was a Weber's task, created in Germany in 2012, and it was for younger ones, for age group cadets. Cadets are grade 7 to 8, yeah, grade 7 to 8, and you see there's a story at the beginning. We have a big beaver and a small beaver, and they're standing in this way, back to back, and they follow the same procedure. And the procedure is written in some kind of pseudocode. This should be understandable for everybody, I hope so. But we had no problem with this task. The children understood this easily. To repeat twice, plant the flower on your right-hand side, move one step forward, plant the flower on your left-hand side, and move one step forward. And it is important to read the whole task, because the little beaver has smaller arms and smaller legs than the big beaver. This is important to know to solve this task. So, and this was the result. After some time, there were blossoms and blossoms coming out of the ground. And which one is the correct plant? I can ask you.
What side are they starting from?
Right-hand side.
They're standing like this at the beginning.
One is on the right and the other one, this is this one. That's the one first. What? I'm not sure. I think it's wrong. Are we correct? Come on, tell us.
I have not written it. What's this side? You know it. You can argue why it is correct.
Well, it cannot be the second or the third,
Dagiene,
because the left one is first. So it has to be either the first or the fourth. If we number 1, 2, 3, 4. Because they're evenly spaced. It's supposed to be like larger. It has to be larger, and the steps are the same, right?
Oh, maybe this is 2 steps, this is 1 step. Maybe it's in the...
The larger has...
I recommend the first one, top left.
So, who is for this solution on the left upper corner? Who is for another solution? Now so many raise their hands, so nobody else wants to do this. Okay. I think it's correct. Yes. They discussed it already. So you find here, for example, these are small steps for the big ones, cannot be the solution. And it starts with your right hand side. So if if you look at from top, you see this starts here right, and here starts right the other one.
So how do they give the answer to you?
Give the answer?
Yeah.
Oh yes. Yes, this is just on the on this slide. This is a kind of multiple choice task, and this is 1 out of 4 is correct. This was usual from the very beginning of the Pepper's contests. That at the beginning we had many multiple choice tasks, and 1 out of 4 was correct. This was the rule, because then the students have not much time, and if there are more than one maybe correct, this is too difficult for the young one. So usually we have A, B, C, D. We have more than one system available. More than 10 in about 36 countries. We have more than 10 systems. But it is a kind of multiple choice. Anyway.
And where is the education?
Yes, this is a very good question. This is a good question. Where is the computation? This I wanted to ask.